Welcome all. In the last session, we seen about the construction of the decision tree and the classification using the decision tree. Today we are going to learn one more important technique that is called regression. Today we are going to study how to perform a regression analysis and what are the different uh, correlations and relationships associated with the regression, and we study a simple numerical on the regression analysis. Regression analysis is a form of predictive modeling which investigates the relationship between a dependent and independent variable. This technique is used for forecasting, time series modeling, and finding the causal effect relationship between the variables. For example, if I want to find the relationship between rash driving and the number of road accidents by a driver, it is best studied through the regression. Regression analysis is an important tool for modeling and analyzing data. Here, we fit a curve or line to the data points in such a manner that the difference between the distances of data points from the curve or line is minimized. Regression is a well-known statistical technique to model the predictive relationship between several independent variables and one dependent variable. The objective is to find the best fitting curve for a dependent variable in a multidimensional space with each independent variable being a dimension. The curve could be a straight line or it could be a non-linear curve. So when the curve is straight line, we call it as linear regression, and when it is a non-linear, we call it as a logistic or a polynomial regression, which basically called as a non-linear regression. The quality of fit of the curve to the data can be measured by a coefficient of correlation R, which is the square root of the amount of variance explained by the curve. So let's see what are the steps for the regression. The first step is list all the variables available for making the model. Then establish a dependent variable of interest. Then third is examine visual relationship between variables of interest. Then last is find a way to predict the dependent variable using other variables. So next we see what is correlation and relationships. Correlations and relationships are very important in case of the regression analysis. The statistical relationships are about which elements of data hang together and which one hangs separately. So what we do in a statistic relationship is we are more bound to find the relationship, that is how close the different elements in the given data. So it is about categorizing variables that have relationship with one another and categorizing variables that are distinct and unrelated to other variables. So what we do is the variables which are related to one another, so that are being categorized as one type of variables, and the one which are distinct, they are kept separately. Again, it is about describing significant positive relationship and significant negative differences. So what are the common similarities or what are the commonalities so that form the positive relationship, and what are the differences that form the negative differences. The first and foremost measure of the strength of a relationship is correlation or correlation. So that is how closely the two items are related to one another. The strength of a correlation is a quantitative measure, and it is a normalized value which ranges between 0 and 1. The correlation 1 indicates that there is a perfect relationship where the two variables are in perfect sync, means the two variables are having a good relationship with one another. In such cases we will get the correlation as 1. A correlation 0 indicates that there is no relationship between the two variables or between the variables, which indicating that the two variables are entirely orthogonal or different. The relationship can be a positive or it can be an inverse relationship, that is the variables may move together in the same direction or in the opposite direction. That is the value, the relationship can be positive if they are in the same direction. If they are in the opposite direction, then we'll get the relationship as negative. So the good measure of correlation is correlation coefficient, which is the square root of the correlation. So if we take into consideration the value presence of negative values, so it's better to go for correlation coefficient rather than just going for the correlation. Correlation coefficient is the square root of the correlation. So the coefficient value, which is called R, is ranging between -1 to +1, whereas correlation value is between 0 and 1. The coefficient of correlation value is between the -1 to +1. So in this case, an R value of 0 indicates that there is no relationship, and an R value of 1 shows perfect relationship in the same direction, and an R value of -1 shows a perfect relationship, but the relationship is moving in the opposite direction, or the vectors or the variables or the features are having a opposite natures. Given two numeric variable x and y, the coefficient of correlation R is mathematically computed by the following equation: R equal to x minus x bar into y minus y bar divided by square root of x minus x bar square into y minus y bar square. So here x and y are the given values, and x bar and y bar are the corresponding arithmetic mean of x and y values. So that's how we compute the value of R, that is coefficient of correlation. Okay. So how to represent, how the regression data is being represented is a scatter plot is a simple exercise for plotting all data points between two variables on a two-dimensional graph. So normally the data points are being represented with the help of the scatter plot. It provides a visual layout of where all the data points are located and in the two-dimensional space. So this is how the two-dimensional scatter plot of the data points is being represented. So this is a linear in the increasing direction, in the increasing with the increasing value, and this is a again it's a linear representation, but it's in a decreasing format. So this is a non-linear, so this is a collinear. So this represents no relationship and no relationship, because there is no any place where the more number of data points are being present. Okay, so whereas if we look at the above four places, so we can judge somewhere there is a relationship between the data points. Let's look at one simple problem on the regression. So that is, the regression model is described as a linear equation. Y is the dependent variable, that is the variable that is being predicted. So y is the one which is to be predicted, and x is the independent variable or the predictor variable. So y is a dependent variable and x is an independent variable. There could be many predictor variables such as x1, x2 in a regression equation. However, there can be only one dependent variable, y, in the regression equation. So a regression equation is being represented in this way. So that is y equal to beta 0 plus beta 1 x plus epsilon, where beta, so this equation appears, it's similar to the straight line equation, that is y equal to mx plus c. So where beta 1 is the slope and beta 0 is the y interrupt, plus the epsilon is the error values. A simple example of a regression equation is to predict a house price from the size of the house. So given the data set in this way. So the house prices are given and the house size is being given. So for 1850 square feet space, the house price is $2,29,500. So for a size of 2,190, the house price is $2,73,300. So in this way we have a data set which contains house prices and depending on the space. Now we make a scatter plot of the given data. So that's how a scatter plot and regression equation between house prices and house size are just given below. So this is the house price, that is it shows some linear relationship, and then after finding all the calculation, so we found the relation, that is coefficient r as 0.891. So the measure of total variance equal to 0.794, that is 79%, and the y-intercept we found is minus 54,191, and the slope is 139.48. So the equation of the straight line, we know that y equal to mx plus c, where m is the slope and c is the y-intercept. So c can be found by substituting values of x and of x in y equation. So the final regression equation is this house price in dollars equal to 139.48 into size minus 54,191. This equation explains only 79% of the variation in the house prices. So how we arrived at this values or at this equation? So that is a detailed step is given below. So first calculate the mean of x values and the mean of y values. So that is x bar and y bar. So after calculating the mean, so find the slope of the best slope. So that is x minus x bar, xi minus x bar minus into yi minus y bar divided by x minus xi minus x bar whole square. So using this formula, so calculate the that is the slope of the given values. Then compute the y-intercept of the line using formula b equal to y bar minus m x bar. So where b is the y-intercept. So if you look at this equation, so here we have c as the y-intercept. Okay, so we can find y-intercept c equal to y bar minus m into x bar. So what is m? M is the slope, x bar and y bar are the arithmetic mean of the given x and y values. Next, suppose so in order to enhance the predictive accuracy of the regression model, so we can consider few more features to be added for the given data set. Suppose other predictor variables are made available, such as number of rooms in the house. So for determining the price of a house, one more factor that is important is how many rooms are there in a given house. So space is also one of the important consideration. Apart from that, the number of rooms is also one of the important consideration for judging the house price. So that is again, that will again improve the regression model. So the given data set is modified and it is being added with a one more feature, that is rooms. So house price and the size, they are same. The next column that is added is the rooms. So for 4 and 5, 3, 2, so these are the number of rooms added to the given data set. While it is possible to make a three-dimensional scatter plot, we can iteratively examine the correlation matrix among the variables. So this is the value of uh, the total given data set. So how we arrive at this is, so we can find the value of y using the y square. So then x1 into y, then summation of x2 into y. So then x1 r of y x1 x1 square, then x1 x2, then r of y x2, then r x1 x2, then summation of x2 square. So this is a kind of the polynomial regression, so where we have more than one value, where we have more than one uh, where we have more than one features. So according to this, it shows that the house price has a strong correlation with the number of rooms, as with the number of rooms, that is 0.944 as well. Okay, so if we look at this, so if the relationship between house price and size is 0.891, and the relationship between house price and rooms is 0.944, so it indicates that even consideration of rooms is also the most prominent thing in determining the house price. So adding this variable to the regression model will add to the strength of the model. So running a regression model between these three variable produces the following output. So what is this output is, so here r we have is 0.984, r square is 96.8. Then if we look at this, the accuracy of with the adding the number of rooms is greatly improved as compared to the value of the r, that is before adding the number of room. Before adding it was somewhere around 79%, but now it is somewhere around the 96%. So then what is y-intercept? Y-intercept is 12923. Then the slope is 65.6 and the number of rooms is 23, that is the room value is 23613. So this is the equation how we can fit with the number of different features. So that is a equal to y bar minus b1 x1 bar minus b2 x2 bar. So the regression equation is now being given in this way. So this is the modified regression expression for the house price prediction. So suppose if a situation is given below like this, now can we predict the house price? So that is the main thing in the regression. So given a new data set, how we can predict the price of the for a new data value. So given a situation below, it will be possible to predict the price of a house with 2000 square feet and 3 rooms. Now if I give the value of, so I found the regression equation by analyzing the given data set, and this is the regression equation. And once I got this equation, now whenever we have a new data value, so we need to just substitute the values and we will be able to arrive at the prediction values. So if we look at this, the substitute the value of size in the given equation, that is in the regression equation, and the number of rooms is replaced this with the 3 in the regression equation, and once we substitute this, then we will come to know what will be the price for this house with these given values. So that's how we computed. So 65.6 into 2000, that is the size of the house, and the number of rooms is 3. So at the final we arrived at the value as $214,963 for 2000 square feet space and number of and 3 number of rooms. So this is how we can predict the value of the any of the any of the data using the regression. The most important thing here we need to remember is about the finding the regression equation. So once we are able to arrive at the regression equation, then we can easily predict the value for any of the datas. Okay. So that's for the today's class. So let's summarize what we studied. So regression is a simple, versatile graphical tool with high predictive ability. So once we find the regression equation, so we can easily predict the values for the new data value. They include non-linear as well as binary predictions. So the one which we have seen earlier is the linear regression. So even with the help of the logistic regression, we can find the non-linear relationships also. Then regression model should be used in conjunction with other data mining techniques to confirm the findings. So this regression mainly resides on the statistical implications. As we have seen, it fully depends on the that is the arithmetic mean and the different statistical parameters. So if we use this in conjunction with some other data mining techniques, so that will enhance um, the accuracy of the given value, or the that will make the prediction more accurate. Okay, so that's for the today's class. Thank you.